Today's topic is calculating reactions, and we have a case of simply supported beam that has two supports, roller and hinge. And as we have learned before, the roller support can resist only vertical forces, and let that force be upwards, because the assumption is up to us to assume upwards or downwards, and the calculation will prove our assumption is correct or not. And then for the hinge support, the reaction will be vertical, and again we'll assume this upwards, and horizontal. And let's assume the horizontal reaction is towards west. And we'll name them. We'll name this support to be RAY, and this to be RBY, and this is RBX. So if we look at the after analysis, we have three unknowns. We have RAY is unknown, and RBY is unknown, and RBX is unknown. And mathematically, to be able to resolve a problem with three unknowns, we need three equations. And if you remember, we had before the equilibrium equations. The equilibrium equations are composed of sum of all forces in x direction is equal to 0, and sum of all forces in y direction equal to 0, and sum of moments above certain point equal to 0. So we have here three equations which we can use to calculate these three unknowns. Now the point here is we need to first of all plan as how do we approach this to solve this problem, and we can apply these rules. So where to start with? The best way to start with is that we take the moment about a point where we can cancel out two unknowns, and that will be point B. So if we take moments about point B, this point here, we'll cancel out RBX and RBY, and which will have an equation with only RAY to be unknown. So that will be easy to solve. And once we do get the value of RAY, then we can move to the sum of all forces in y direction equal to 0. Then we get the value of RBY, and once we get the value of RBY, then we can apply all forces in x direction equal to 0 and get the value of RBX. Now that we decided we'll take the moments about point B, we need to first resolve the inclined forces as we learned before. And we have only one inclined force, which is F1. That will be the x component of it, and this will be the y component for this force. And of course the force itself extends like so, so we know the angle here will be 40 also. So the value for F1x and the value for F1y need to be calculated, and we know this from previous classes. This will be the F1 cosine 40, which is equal to, I'll put this in this color so that we know it is 13.78, and F1y is equal to 11.57 kilonewton. So now we have the perpendicular distances for each one of them. The next step is to define the rotation direction. So the rotation direction for RAY will be clockwise, which is negative, and the rotation for the F1y is counterclockwise, which is positive, and F1x aligns through the point B, meaning it will pass through, this will pass through point B, so it makes no perpendicular distance. That's why this will cause no rotation. It will have no rotation. And then the force F2 will rotate counterclockwise, which is positive. And of course RBY and RBX, they do not cause any rotation because both of them pass through the point B. Now let's do the calculation. We'll do the sum of all moments about point B is equal to 0. And this will start with the first one is minus RA y multiplied by a distance of 3 plus 5 plus 4 is equal to 12 meters. And then we have the Fy component, which is positive, plus F1y is 11.57 kilonewton, and the perpendicular distance between F1y and point B is 5 plus 4, which is 9 meters. And then we have F2. Of course, we said F1x causes no rotation because it passed through point B. We move to F2. F2 is positive, the rotation for F2, plus F2 is 20 kilonewton, and the distance, perpendicular distance between F2 and B is equal to 4 meters, is equal to 0. So if you look at this equation, we have only RAY is unknown, and if you isolate RAY, you will find RAY is equal to 18 plus, that is 18.09 kilonewton. Because the sign is positive, it means that the assumed direction for this reaction is correct. So actually we can put this notation saying this is the direction for the reaction, because the reaction is a force after all, and we have to, this force will have a magnitude which is 18.09 and has a direction which is upwards. Now once we got the value for RAY, we say we'll move to sum of all forces in y direction equal to 0 equation, and this equation we have the RAY is upwards plus RAY, and the F1y component is negative downwards, so minus F1y, and then F2 is downwards, is minus F2, and the assumed direction for RBY is upwards, so say plus RBY is equal to 0. Now if we substitute the values, so RAY is plus 18.09, and F1y is equal to 11.57, and F2 is equal to 20, and plus RBY is equal to 0. Now if we isolate RBY, we'll get a value for RBY equal to 13.41, that is kilonewton. So we got the value of RBY also. Now what's left is the RBX. We'll apply the equation, equilibrium equation, sum of all forces in x direction equal to 0. And in this case we have only F1x, which is going towards east, plus F1x, and the assumed direction for the reaction is going towards west, which is minus RBX is equal to 0, and F1x is equal to 13.78 kilonewton, minus RBX is equal to 0. Now if you isolate RBX, will be equal to 13.78 kilonewton, and again the sign is positive, so it means the assumed direction is correct.